All right, guys, so here's your warm-up. Go ahead and get started. All right, so this should be very familiar. This is something that we did very recently, was solving quadratics. This one here should be very easy because you don't have a middle term, which means you can basically go ahead and straight up solve it using our square roots method. Now, could you graph this? Yes. You could graph this and then find the zeros using your graph, and that is an easy technique to be able to get this answer. But you can also do it like this and get your two answers as well. They want the positive solution, that's why our answer is going to be +3. You can bubble it in like this, like we have discussed before. You also technically, for the positives, do not have to put the plus sign. You can just put the answer if you want. But if you're ever negative, you must get the negative answer. All right, transformations. That is, we're going to talk about today, quadratic functions. First off, let's go ahead and review all of our transformations for a quadratic. Now, whenever you have a f of x, these are examples where, for instance, you have 2 f of x. In that case, you would have a vertical stretch. In other words, your parabola got skinnier. If on the opposite end you had a 1/2 f of x, you would have a vertical compression. Your parabola got wider in that case. If this was a negative, though, then that would mean you would have a reflection over the x-axis. For f of x plus d, examples of that would be f of x plus 9. So in that case, you would be going up 9. So as long as you're adding, you're going up. If on the opposite end you are subtracting, that is examples when you're going down. For both up and down, you should label how much you're going up and how much you're going down by. Next, f of x minus 9. This would be an example of moving to the right 9. If you had f of x plus 5, this would be an example of moving to the left by 5. With the left and right, it's the opposite of what you think they are. Subtracting means you're moving to the right. Adding means you're going to the left. Lastly, f of b of x. If you had f of 2x, this would be an example of a horizontal compression. That is a case where if you have a horizontal compression, your parabola is getting skinnier, okay? If on the opposite end, though, you had f of 1/2 x, this would be a horizontal stretch. In that case, your parabola got wider. Let's go to some examples. When it comes to parabolas and you're naming the transformations, just look at the equation if you have it, and if you don't, look at the graph. Figure out how did it change from the parent function, f of x equals x squared. Well, in this case, I have a -1, and that tells me I went to the right 1, and I can see that here on my parabola. It went from the vertex to the right. Here I have -3. That means it went down 3. And I can see that here on my parabola. Next. All right, this one I can see I have a lot of different numbers. Let's start with the easier ones, the +4. That one there, my parabola shifted up 4, and I can see that again in my equation. If I move to the next one, the plus x plus 4 inside the parentheses, that shows me that I went to the left 4. The negative here, that tells me my parabola flipped upside down. And that's how I know I have a reflection. Now comes the last one. The last one is probably the hardest one to identify. The key thing to remember is that the 2 on the outside tells you that it is a vertical. And since it's a 2, it's going to be a stretch. Anytime that your number is bigger than 1, that is how you know you have a stretch when it's on the outside. Next one, again, this one actually is kind of easier to identify than the last one. First off, I can see my parabola move to the right, and so that's how I know it went to the right by 3. My parabola is flipped upside down. That's how I know I have a reflection. All right, now let's get to some attributes. Our attributes here, first off, we have the axis of symmetry. Your axis of symmetry is going to be where you have a parabola, and your axis of symmetry is the line that cuts your parabola in half. It's written as x equals a number. That number is the x value of the vertex. All right. Your y-intercept. As you all know, the y-intercept is where you cross the y-axis. All right. So if I'm looking at my parabola, let's get a better picture here. This would be my y-intercept. And I do need to write it as a coordinate. It would be 0, comma, whatever number that is. Next, my vertex. My vertex can be a maximum, which means it's my highest point, my highest point, or it can be a minimum, which means it's my lowest point on my parabola. It's going to be written as a coordinate. It's your turning point. So for instance, if this was my x and y, if this was my graph, and then there's my parabola, the turning point, that lowest point, would be my vertex. Next, we come up with the x-intercept. The x-intercept is where, as you know, it crosses, your parabola crosses the x-axis. You can have 2, 1, or none when it comes to your x-intercepts. If you have 2, it's going to look like this. If you have 1, it's going to look something like this. If you have none, it's going to look something like this. These x and y, x-intercepts have other names as well. Don't forget, x-intercepts can be called roots or zeros. Your domain are the x values on your parabola. Your range is all the y values. When it comes to your domain, as long as it's not real world, it's all real numbers. Your range is either y is greater than or equal to a number, or y is less than or equal to a number. And that number there is the y value of the vertex. All right, let's take a look at an example here. So first things first, let's identify our x-intercepts. I see I have 2 of them right here and right here. X-intercept is -2, 0 and 4, 0. My y-intercept is right down here. It is -8, 0. Actually, wrote that wrong. Remember, it should be 0, -8. Vertex is this point down here. It's the lowest point. We can add in that is a minimum. And the coordinate is 1, -9. Axis of symmetry is this line right here where I cross the x-axis. And it cuts my parabola in half. X equals 1. My domain, since it's not a real situation, is all real numbers. Range is y is greater than or equal to -9. What transformations occurred from the parent function? It went right 1 and it went down 9. All right, guys, go ahead and go work on your homework in Canvas.